So today I'm going to just continue with the Linux overview. I'm going to talk a little bit about command IO, input and output to programs in Linux, and some other command utilities that I find helpful. And again, this is culled from a lot of the different activities that I do as a system administrator. I'm sure other people with more experience could offer some additions to this. The thing I want to talk about first is command input and output, as well as command errors. Typically on Linux, so Unix and Linux are tied to a C programming model. It's just kind of like built in. And the model has 3 special file descriptors. Every time you start a program up, you'll create 3 file descriptors, or you'll inherit them from your parent. And these are standard in, standard out, and standard error. So standard in refers to standard input. And if you write your C program and you do a scanf, or if you're doing C++ and you do a cin, less than, all of that stuff is basically defaulted to the keyboard. You can redirect standard input from other sources, but typically by default, it's your keyboard, standard in. Likewise, standard out, whenever you do a printf, or whenever you do a cout, or whatever println is the Java thing, that by default will go to your screen, and that's called standard out. There's another file descriptor called standard error, and you probably didn't do this in CS201, but like if you have errors, you don't want to mix the error output with your program output necessarily. So the C programming model has a separate file descriptor for the error messages. Now, by default, it also points to the screen. So as a user, you can't see the difference between standard output and standard error output, but these are on separate file descriptors. You can actually point standard error to some other place and then get your errors separately, which we'll talk about next. So if you have an exceptional case in your program, you'll error out. And I think most of the higher level programming languages also will allow you to send error output onto standard error, like Python and Java. So one of the things that you might see is if you do an ls on a file that doesn't exist, you'll get this permission denied, or so if you don't have access to the file, or if it doesn't exist, you get these error messages, and those are basically out of standard error. Even though you can't tell the difference because they're all on the screen. The file descriptors have fixed numbers. Every time you write a C program, these 3 file descriptors have integers 0, 1, and 2. These are their handles in your C program. I think that's all I wanted to say about that. Okay, you can view any process's file descriptors under /proc. And so if you go to /proc and you fill in the process ID, this is a directory that has a description of all of that process's resources. And if you go into the proc pid fd directory, it's a directory that shows every single file descriptor that process has open. This is very important because if you have a sus process on your system and you're like, what's it got open? You can go there and figure it out. Like you say, oh, it's open to socket, or it's open to etc password. You're like, that's not good. I don't want that on my system. But this allows you to investigate that. So there is a special directory called /proc/self. That's a pointer to yourself. It's a symbolic link that gets updated based on the process that's trying to access that directory. And so as a program, so here I am in the shell. If I do an ls-l of proc self fd, this is going to print me all of the file descriptors that ls has open. So it's kind of like self-inspection. This ls is basically what this command does. And you'll go there and you'll get something that looks like this. You'll see file descriptor 0. This is standard input. Well, that's pointing to my terminal, my pseudo terminal. So if I SSH'd into this machine, and the SSH process has owned dev pts0, that's my pseudo terminal. So the input's the terminal, the output's the terminal, and the standard error is the terminal, 0, 1, and 2. And then as a result of doing this ls-l, I have to open up this directory in order to list it. And then you can see that the fourth file descriptor here is basically that directory that I'm listing. And in this case, proc self, the actual PID of the ls is actually this number, 2390553. Okay. Does that make sense for people? That's a useful utility, so I threw it in there. Okay, in the shell, you can redirect these file descriptors, these standard file descriptors 0, 1, and 2 to come from and go to whatever you'd like. So in Unix, everything's a file. So you can point it from a file, point it to a file, and you'll see this a lot. The first shell character I'm going to talk about is the greater than character. And this character redirects standard output to a file, and you'll see this a lot. So here's an example. I list public HTML, and it's got this subdirectory, CS491. And then I can say, you know what, I'm going to do another ls, and I'm going to redirect the output rather than going to the screen. I'm going to redirect it to a file. And so now you see there's no output to this command. But if I do a cat on output.txt, you'll see that the listing is there. And it's a long listing of the directory, and it's got all the permissions. Okay. The double greater than is append to the file that's there. When you just do a single greater than sign, it'll create a new file. But a double greater than says, you know what? If that file exists, I just want you to append the output to that file. So in this case, if I do a ls-ld of public HTML/CS491, and I say append it to this previous file, then when I do a cat on output.txt, I get something that looks like this. Okay, so that's the append. Likewise, I can redirect standard error. So in this case, I put the file descriptor number of standard error, which is a 2. And so if I want to save the output of the standard error in a separate place than standard out, then I can do something that looks like this. So in this case, I do an ls-ld of public HTML, just like this one. And so I know what the standard out is going to be. It should be something that looks like this. And then I try and list a non-existent file, and that's going to produce an error. And I'm going to tell this command line, I want the output to go into this file, and I want the errors to go to a different file. So I cat the output.txt, it has the original thing, and then I cat errors.txt, and it's got that error message. Yes?
So you have the 2 errors, would it automatically put the errors in the output also, or would it just not show?
So that's a good question, actually. If I would have just done ls-ld public HTML non-existent.txt and then greater than output, then what I would have gotten was error. This error message would come to my screen, and then the standard out would still go to that file. Because I didn't tell the standard error to go anywhere else, so it just defaults to the screen. That's a good question. Okay. Likewise, I can append with the standard error. And so if I do a 2 double greater than, so I'm listing another non-existent file, and then I'm going to append that error message to errors.txt, and you'll see that the second file doesn't exist either, and it's appended to that first file. Okay. You can also redirect input. So it's basically the less than symbol in the shell. So what's an example of this? So here I do an ls, and I take that directory listing and I send it to a file, and then I run cat-b. Cat-b is like, give me the file contents, but then attach a line number. It's a pretty useless. Well, I mean, maybe you do want line numbers at some point, but like, it's just going to put line numbers in front. And then I want, in this case, when I do a cat-b, rather than giving it a file to cat out, I'm saying, you know what? I want you to take the input of the cat command from foo.txt. And that's basically what's happening here. And so it takes that listing, and then it just line numbers them from the input. There's also a double less than, and this has got much crazier semantics than the single less than. It says redirect standard input specifying a pattern to stop redirection for. So the function of this, the reason why this exists is you'll see this in startup scripts for initializing virtual machines. So maybe not in this class, but in the cloud class, if you want to launch a new virtual machine and you want it to execute a script, well, often you want to be able to create a script in your own script and then execute it. And that's what this double less than is being used for. So here's an example of this double less than. I want you to use cat, and then the input of this is going to come from the following text, and take the following text all the way until you see a flag called EOF in a single line. And then I want to redirect the output to hello.bash. And that's basically, after you execute this, you'll drop down into basically the cat program, and you'll be entering in these strings until you are done entering this text, and then you do an EOF. And then what this does is it takes this content and puts it into hello.bash. Okay, if you do a cat of hello.bash, you'll see this, right? It stopped at the EOF, and then it took this input, and then it just created that file. And then you can execute that file. So in virtual machine startup files, you'll often see a script, the initialization script, sent in like this, and then you'll follow that with executing that script. So just in case you're in the cloud class and you see that, that's what it's doing. That's the script. And then you execute the script and it says hello. I'll talk about shell scripts later on in this class. So that might not make sense to you right now, but it will hopefully at the end. Okay, the next thing I want to talk about are pipes. So a pipe is a facility where you can take the output of one command and send it into the standard input of the next. So that's this character in the shell. That's how that gets interpreted. One of the common examples of this is that I want to do a recursive listing of a particular directory. It's going to dump a huge amount of output on me if it's a directory that has anything in it. And so I want to like pipe that into maybe a pager. So that's what less is. A way of being able to scroll up and down the output. And that's what the pipe allows you to do. Take the output of that ls command and pipe it into the less pager. So you will see that pipes allow you to implement a functional programming style of navigating data in the shell. And this pattern is very prevalent in computer science. You will see this if you take the functional programming class, or that's not the functional programming, well, this is the functional languages class. But if you take the undergraduate programming language class, CS 358, or even the graduate PL class, CS 558, you'll see a functional programming style is being you'll see the strengths of a functional programming style. And this is evident in, if you do any data processing in the Unix command line, this is evident in the way Unix was designed. You will see similar concepts in the cloud class, because in the cloud class, you're doing this functional data manipulation using cloud resources, dynamically allocated. So this is towards the end of the cloud class. This is a quote from Alfred Aho, who's a very famous computer scientist. He wrote the algorithms book that I think some of you might be used in this curriculum. But it basically, the pipes in the Unix command line allowed you to basically take a function composition approach to processing data. And this is an example by the end of this class that we'll go through, where you take 4 different commands and you pipe the output of one into the input of the other, and then that produces an output that you send to an input of another command, and so on. So we'll go through this once I've explained what all these commands are that I'm going to use the pipe for. Okay, some other fun utilities that I find useful, the calendar and the date facility. So the calendar facility just prints the calendar for a specified month or year in history. And so here's an example, cal of September of 1752. Does anyone know what happened in this month? Neither did I until one of our new instructors mentioned this to me. So I figured, oh, I'm going to use this. This was a very famous month where we got 11 less days because we switched from the Julian calendar to the Gregorian one. So that's just an interesting tidbit, but you can get that. So the Cal program knows that, but maybe not anyone else. The date utility, this is really useful. It just prints the time in different formats. So here's an example. You run date by itself, and then you see this date here. And then if you give it a formatting symbol, so %D, %T, that'll give you this date along with the time. So the date and the time format is given. The reason why I say this is useful is that it's often the case when you have log entries in audit trails, they like to index time using a single integer. They don't like structured time because it's hard to sort, right? I don't like, if you have to write a program that's sorted by date, like it's a pain in the neck. You have to parse the year, the day, the month, and then the different structures of the hour, the minute and the seconds. So that's difficult. And so oftentimes when you go into a log file, you'll see a Unix timestamp given, and that's a single integer. And so that basically is the number of seconds, the number of ticks since the beginning of Unix time, which is January 1st, 1970. But like, if you see one of these things, it's like, well, what is the calendar date of that timestamp? It's like, I don't know. But you can use date for this. If you need a quick and dirty way of taking that timestamp and going into a regular date, you can basically get your own current timestamp by saying, give me the date using, this is the special flag for giving the Unix timestamp. And so this is the number of seconds since the epoch. This is called the epoch, which is the beginning of Unix time. And then you can decode a particular Unix timestamp by using this syntax. And then you get this was the date that's associated with that timestamp. So it's kind of a useful facility. So I wanted to point that out. Another useful one, and I use this quite a bit, is the interactive calculator. Now, obviously, you could use it in a GUI, but I don't like leaving the shell at all. I like staying in the shell, and I don't want to go to a web browser to do a calculator or open up a separate application. So I just do BC. The nice thing about BC is that it's scriptable and it allows you to do base conversions, especially if you're trying to go from binary to hex or decimal to hex. This is one of the easier ways of converting. So here's an example where I say, echo this script that I want to send to the calculator. I want to set the output base to be base 16, hexadecimal. And then I give you an expression, a calculator expression of 10 plus 5. And so the input base is still base 10. And so this is 15. And then when you convert that into hexadecimal, that's capital F. So that's just a simple example. But you can do arbitrary hex arithmetic and make it scriptable using BC. You can also have it be interactive. So if you type BC with no input, it'll drop you in here. You say, I want to change the input base to 16, and I'm going to give you this hexadecimal addition, 3 Fs and an E plus 1. The output base is still base 10. And so it'll give you, this is 65,535, which is basically all Fs. When you convert that into decimal, that's what that is. Are there questions about this? This is like review of kind of CS 201, hexadecimal, decimal, binary. Okay, the next thing I want to talk about is navigating the shell. One of the first things that we need to talk about are escaping shell characters, right? I gave you some special characters like the pipe, the greater than, and the less than. What happens if I actually need those as literals in the command line, right? I don't want the shell to interpret those things if it's part of my file name, for example. If I have a file name that just happens to have a greater than symbol in it, what do I do? And so we talked about this a little bit earlier. We have to escape that character out. And you can escape the character in many different ways in the command line. You could use a backslash, or you could use a single quote, or you could use a double quote. So the backslash will escape one character. The single quote and the double quote will say, treat everything in between as a literal. So if you have a whole bunch of characters, like for example, this, I have a whole bunch of space. I have 3 characters in a row that I have to backslash. Well, maybe I should just put that in quotes and say space, space, caret. So here's an example. So for example, a space is the default file delimiter or argument delimiter on the command line. If I have something that has a space in it, then I'll either need to put the spaces in these single quotes. So in this case, these 3 spaces are treated as literals and I can put it into a file. In this case, if I have greater than and less than symbols, I can also use the double quotes to treat those as literals. And then the backslash also works. And so if I do a cat of foo.text, I get this little bit of ASCII art as a result. Okay, so that's really important as you're entering stuff in to the shell. Okay, the next thing I want to talk about are process environment variables. Every process that starts on Linux and Unix has a set of default environment variables that determine the behavior of that program. And so here are the common ones that you'll come across. What is the host name of the system that I'm on? What is my user login name? What is the username running this program? And what is the UID associated with that user? What is the shell that's being run? How did I get launched? Which shell launched me? The home directory of the user, the current working directory of the particular process, and then a path variable that determines where I'm pulling my programs from in the file system. So these are all environment variables that we'll talk about in different aspects later on. You can get a listing of all your environment variables by doing a printEnv. And so you'll see something that looks like this. So I do a printEnv. That's my username, my home directory. This is my path. So this is a list of directories where I will look for programs to run. So if I type ls, ls will go, well, the shell will go and search the path for the first appearance of ls, and then I'll execute the program that it finds there. What are other interesting ones here? I think I'll just leave it at that. Make a note of this LD library path because we'll talk about that towards the end when we talk about security. Okay, you can get access to any of your environment variables in the shell using the $ character. So this is a special shell character that says, go into the environment and then find the variable that has this particular name following it. So if I do an echo of the $UID, it will go into the environment and figure out, well, where is UID set and return that number. Likewise, the current working directory is /temp. The user is me, the shell that I'm using is Zeesh, and then my home directory as part of the shell. Okay, the next thing I want to talk about are shell variables versus environment variables. Now, this is something that if you don't get straight, it could cost you hours of your time. Well, it cost me hours of my time. So hopefully 1 minute of your time on this slide will save you those hours that I wasted on mine. There's a difference between a shell variable and an environment variable. A shell variable is a variable that you can set that is local to your current shell, and it doesn't get passed on to processes that you might invoke. Okay, so in this case, so I should say sub-processes of your current shell don't inherit these values that are local. So I can set a shell variable by saying the variable name is equal to some value. And then if I do that, so in this case, I have a shell variable foo, I set it to bar, and then I echo that variable and I get bar, which is fine. If I execute a shell, another shell, bin bash, and then I echo that variable, you see it doesn't get inherited by the subshell or by the second shell. This is different than an environment variable. An environment variable is actually passed into the subprocess. So if and you set it with the export command. So I'm going to do the same thing. I'm going to create this environment variable instead, do an export of foo and bar. I echo $foo and it's bar. All is fine is good. I execute bin bash, and then when I do this echo, I'll see that the bar is set. Okay. I don't have an example of using it in scripts that matter, but keep this in mind that these two are different. Okay, we talked about this path variable. The path environment variable determines where you're pulling your programs from. So ls, when I invoke ls, it searches the path variable. If I want to figure out where the binary is for ls, I just type which. Which ls am I using? And so in this case, I do an echo of my path, and you can see it's got these directories that it searches for to find ls. Well, when I do an ls, it'll search for these directories. If I say which ls, it will actually tell me where it's picking up that binary from. And in this case, it just happens to be in the very first directory in my path. So it's going to search from left to right, and it's going to stop its search when it's found the program. And so it's bin ls. Okay. You can, yes?
Can you change the environment variables just from the...
Yeah, so the question is, can you change that thing? And yeah, in fact, adversaries will want to change it on you. And so we'll talk about, you should always know what your path points to and make sure it's always pointing to places you trust. Yeah, we'll talk about that. We'll talk all about command hijacking. In fact, we'll start with this one. The alias command, it says, you know what? I don't like a particular program or a command, the way it works. I want to create an alias so that when I type that command, I get something else. One of the aliases that's common is before there was a less, there was a more as a pager, and more was terrible. You do more on a file and the scrolling didn't work quite right, and you couldn't search. It was a terrible pager. And so what people started to do, so then less came along. Less is a differently named program, and it's got all the facilities that you want in a pager. And then people were aliasing more with less, because habitually, when you learn more, you're typing more file, but then you're like, I don't want to learn a new command, and I don't want more. And so you would alias more to less, and then when you type your more, you got less. So that's probably confusing, but that's basically what an example. More common though is that you're going to alias a command to add particular flags that you find most useful in conjunction with that command. Maybe the default operation of that command isn't what you like in your command, and you create an alias for that. And then if you don't like that alias, you can do an unalias to remove that. And aliases are typically done within the shell. They're implemented completely in the shell, not in the Unix environment per se. Yeah, so we're gonna, alias doesn't take a flag, but you would add the flags into the alias definition for another command. Actually, I don't think it does, but you could do a man on alias. I don't think alias takes, but we'll see. So here is, if I do a which ls, so if you SSH into my machine and use my startup script, I've aliased ls to ls -- color equal tty, because I like color output. And by default, ls doesn't give it to you. So I'm like, okay, well, if I have a color terminal, I want a color output. So that's what that does. But maybe I don't like that alias. Maybe I know I'm going to be in black and white forever. So I'll just unalias it. And then if I do a which ls, and then this is not color output, so it doesn't matter, you'll see it goes back to the original ls. Okay. And then if I do my ls, I have a directory, a regular file, a script, and a symlink. It all looks very plain. And you're like, yeah, that doesn't help me. I have to actually do an ls-l to figure out the file type of each one of these files. I don't like that at all. So I'm going to do an alias. I'm going to say alias ls, and I'm going to use this flag. And this flag is the -F. It's like, give me a format type hint on the file that I ls. And then if I do an ls, I get something that looks like this. File annotations on the ls. I get a / at the end of the name if it's a directory. Regular files don't have anything. If it's an executable file, it'll put a star there. And if it's a symlink, it'll put an at the end of it. So that's an example of a useful alias that you might put in your startup file, for example. Okay, in order to initialize a whole bunch of aliases, you don't want to SSH into a machine and then have to type all your aliases in. So you will typically want to create a set of alias commands to run, include it into a file, and then in one shot, execute that file. Now, the way to do this is with the source command. This says run all of the commands in this particular file within the current shell context. That's the source command. And typically, when you start up, you're going to source your shell startup files, some kind of shell configuration that you have set up to configure your shell. If it's bash, it's often the first two things, the bash profile or the bash RC. If it's Z shell, then maybe it's the bottom two, zshrc and zshen. Question, yep.
Are the bash RC and the bash profile usually different things?
That's a good question. I actually don't know why there's two of them. So it used to be that the profile was something that it was just a dot profile, and it was something that any of the shells would source. And then you would have a specific one for your kind of shell, like bash RC, that would have the language of your shell. I don't know why they decided to create a bash profile separate, but that's a good question. I actually don't know the answer anymore. I think it's just like the naming. Actually, if you find the answer, send it on the Slack. Yeah, why are there two things? Well, now there's more than two. Actually, some of these shells, like you go in there and they're including directories of files to source. And if I want to customize my Z shell now, I have to go through a directory tree to find the place where the thing got defined. Yeah, it's kind of a mess. Did someone have a question out here? Yeah.
So my question is, you told us that keep all the aliases in one file.
Typically, yeah, you would want to keep your aliases in one file. Yeah.
My question is, at one point, can you skip any of the commands and run them? Like, if we don't want to use all of them?
Oh, so the question is, if we don't want some of those aliases, you would just have to comment it out in that file. Like, as long as you're sourcing that file on startup, it's always going to define that alias. You have to just comment that thing out. And if you have already executed and defined the alias, then you have to manually do the unalias to undefine it. Yeah.
I guess you can maybe do a script that has unalias.
Yeah, you could do that as well. You could do a script that's to unalias it and then source that script. Yeah. So here's an example. This is back to the color listing example. This is what I would recommend all of you define your shell to be. Like if you want to, I mean, this is what my current shell setup is, which has been a lot of trial and error to find out what I like. And so if you like some of this stuff, I would suggest this. So here I am in Z shell, and I'm at the PS1 environment variable is basically your prompt in Z. It says, what do you want me to print as your command line prompt? And so it's vanilla %. So this is why the prompt is %. And then I say which LS, and it's just regular LS. And when I do an LS, there's no color, there's no file annotation, there's nothing. And then I'm like, oh, well, you know what? In my Z shell RC, I want to put this. I want to say alias the LS to be not only a -f, but add the color stuff to it. And then I want to do a fancy prompt. And this looks like, wow, this is like a total programming language. I don't know what any, in fact, I parse this, I kind of see what it's trying to do, but I don't know any of the syntax. This is a programming language I don't want to learn. I just copy and paste from someone else's and it works. And I don't think there's any malware in there. So I think it's good. You have a question?
Can you post that on Slack?
I can actually, if you give me a reminder. And then what it does is it redefines my prompt and LS to give me something that looks like this when I do an LS. So it gives me my username. It gives me the host that I'm currently on. It gives me the time. It gives me the current working directory that I'm in. If the current working directory is a Git repository, it gives me the branch. And it tells me whether or not I have unstaged, or if I have files that have been modified in this repository, which is this red star. It says you got unmodified stuff in there. So I like that prompt. That prompt helps me out a lot. And then color listing, I'm sorry about the contrast here. You know, it's got directories that are colored blue and then have the slash, and it's got executable scripts with the star, color coded, and then regular files are in white. Okay, so that's one thing you could put in your startup script just to make your command line more functional. Okay, and you'll see default startup configuration files across defined in the etc directory. So in etc bash.bashrc, anytime you create a new user and you specify bash as the shell that that user wants to use, what happens is this file gets copied into that user's initial bashrc. So that's just a detail that's worth knowing. Okay. On Linux, you can use the command line to invoke multiple shells in one command. These things are called subshells, and you can invoke a subshell in multiple ways. You can use the left and right parentheses, or you could use backticks to invoke that subshell. We already talked a little bit about the semicolon being able to separate out subshells. In this case, we're talking about the parentheses and the backticks. So here's an example. I set a shell variable now to be the output of this set of commands. So it executes a sleep and then invokes date, sends the output to an environment variable, and then it defines not environment variable, shell variable now. And then this is the output of that command. Likewise, I can just do the same thing with backticks. So if you ever have an output of a command that you want to save off into a variable, you can do this using backticks and then the dollar parentheses syntax. Okay. So we talked about sourcing files to execute a bunch of commands in the current context. There's also shell scripts. So shell scripts are a collection of commands that you want to run in a separate process. You want to invoke a new shell to execute those commands in a separate process. And so this is the distinction between sourcing a file and then executing a script, is this. In order for you to define a shell script, all shell scripts have to begin with a pound bang. This is basically what these two, so the number symbol and the exclamation point, and then the path to the shell program that you've written your shell script in. So if it's a bash script, then you would do bin bash. If it's a Z shell script, it would be bin Z shell or user bin Z shell. The thing with shell scripts is that the script file itself must be executable. And we'll talk about changing the execution bits next class. In order to show you how this works, the difference between source and shell scripts, I'm going to first introduce these two commands. Echo shell level, SHLVL, tells you how deeply am I embedded in shell execution. So when you log in and you enter into your shell, typically you're at shell level 1. If I enter my shell and say execute bin bash, I'm one level deeper. I have a shell that invoked another shell, so now my shell level is 2. The other command I want to introduce is this process listing. It's a ps-p $. This says, give me the process listing of the current process. And in this case, the current process it's Z shell, and this is the PID of the shell that's currently running. Okay, so now what I'm going to do is I'm going to create this file. I am going to create a bash script that just echoes the shell level, and then prints the PID. If I just sourced this file, source is going to ignore this command, and then it's going to execute these two commands within the current shell context. So the shell level is still 1, which is here. And then the PID, it's still the same level, right? It's the same process. So it's exactly what we had earlier. If I were to execute that, say I made that script executable and then I invoked it, you can see I'm at shell level 2, and it created a new PID in order to execute that command. Okay, so that's the difference between a shell script and just sourcing a file. Are there any questions about that? Okay. So I'm describing all of this in order to talk about something that commonly happens when someone compromises your machine. They'll try and inject rogue aliases and scripts onto your machine to get you to execute things that you don't want to execute. So for anyone who has taken the malware class, what do you think this alias might do? I'm like, you know what? I'm gonna change your SSH. Rather than you running the regular SSH, I'm gonna have you run this command, strace. I'm gonna send the output to a particular file. And then I am going to say on these system calls, read, write, and connect, I want you to dump those events to this file. And then I'll, after I call that strace, I'm gonna invoke the original program. What do you think that does?
Sends that data to somebody else's terminal.
Close. It's a key logger, and it sends it to a file. So basically what's happening, strace is a system call tracer. It says, give me all the system calls and all of the data going through these system calls for the read, write, and the connect. So the adversary wants to know all the data that's going through the system call interface and all the connect information because it's gonna connect to a particular machine. It's trying to steal all your credentials, but it needs the machine, so that's why it logs the connect, and it needs the data going across if you're typing in your username and your password. And then it's gonna send the output to a file. And so eventually the file will get, so if the adversary has a way of accessing that file, this file will get uploaded, temp, SSH password, and then the date will get uploaded, and then they've got your passwords. So this is one of the things, like after they have access to your machine and they want to discover other credentials, this is what they would install. It's like, hey, I know how to get onto this machine, but if there's an administrator SSHing from this machine to some other machine, like the domain controller or something, then I want those credentials too. And if they type those in, I got it, yeah.
So would they need then file permissions to be able to edit the master file?
Yeah. So somehow they've compromised your local account. They've changed your environment to do this. And then they're hoping that that is a stepping stone for them to get other credentials. Yeah, so they already got you. And you can already assume you've already been gotten. Like it's easy to get people. And then this is how they collect more information. There's one of the ways that they could. So that's basically what Team TNT was doing. This is from last year. This is their system call tracing. So when they did a teardown of what Team TNT was doing, they saw this. This is set up poor man's SSH logger is the command name. And so then they're like, if this exists, then just attach this into root's bash RC, right? So the next time root logs in, this thing is running as their SSH instead. And so you have to actually look for this to see that it's been hijacked. So that's the link to it right here if you're interested. In fact, I have several Team TNT ones. I like updating these things because this stuff is just going on like nonstop. And so, but an example from 2010 doesn't have quite the impact as one that is 2021. But this has been around for a while. Yep. Oh, blogs. So the question is, are there any blogs that I follow for this kind of stuff?
Like I saw with Terry Huntington, like for example, they don't just speak that.
Yeah. Most of the time, Google seems to know the articles I like to click on. And so I'm getting a lot of this stuff because I like clicking on them. So, but that's not very much help. I basically go with Risky Business. And Risky Business will point me to Krebs on Security often. And Krebs on Security will often, like one of the things I really like with Brian Krebs's reporting, he'll point you to the actual technical detailed analysis of whatever it is he's trying to explain. And he'll often give you screenshots. And so I bet you I probably clicked through this using either a Risky Business article or a Krebs article. And that's what you would want to look for, to go a little bit deeper than the initial story to actually find the exploit. And I would recommend it for all of you, because when it is explained well, you should be able to understand every exploit, unless it's like some crazy browser vulnerability that's got like memory corruption and heap grooming and all this other stuff. Those, I would say, probably not worth your time trying to understand. But you'll see that a lot of these exploits, you just dig in there and you're like, it's stuff like this. And you're like, oh, that's crazy. But this is why, like, and this is why it's in 2021. I bet you there's an example from this year even doing this. So Linux malware actually has gone way up over the last couple of years, just because of the amount of Linux that's being used right now. And so you'll see a lot of this over the last 2 or 3 years is just, yeah. Naked security is, oh, Sophos. Okay, yeah. So that would be enough. Yeah, Sophos. A lot of the, yeah, I've gotten some stuff from Sophos. Okay, so one way of hijacking command execution with an alias. The other way is to hijack the path environment variable, right? That environment variable that's being searched for programs to run. If I can either add if the adversary can add his or her own directory into the path, or create a Trojan command and stick it somewhere in the path early on, then they've also hijacked execution. So here's an example. I echo the path, and this is what it looks like. I'm like, okay, fine. Which ls? It's in /bin. It's right up front. And then I do an ls, and it's like, okay, that's as intended. But what happens if an adversary does this? So an adversary maybe has access to your environment and says, I'm going to create this command, ls, and it's going to be a script. So this is what we just covered. Create a shell script, and I'm going to say echo, I hijacked your ls, and then do an echo star, which is basically going to list. The star is a wildcard in the shell that says match everything in this directory. I'll talk about this in a couple slides. And then I'm going to make the shell script executable, and I'll talk about this next class, what that actually does. I'm going to change the shell variable for path. I'm going to add the current directory as well as /bin. So now the path is just looking at this, and I have an ls in the current directory that will get picked up before the one in bin. And so now if the victim is going to type ls here, well, first of all, which ls? Well, the ls that's going to run is the one in the current directory, not in bin ls. So you put yourself in front and said, and this is pretty innocuous, right? Like if you put the current directory in the beginning of this, well, some people actually do that, right? Like if you're like in Carla's class and you're doing a GCC of your program, and then a.out is sitting there in the current directory, you don't want to type ./a.out. You want to just type a.out and then look in the current directory. So a lot of people are like, yeah, I'm programming C. I want to actually be able to execute programs in the current directory without having to put /. And so if you put that in your path, and then somebody has put a rogue binary in your current directory, say you go into /temp, cd/temp ls, and someone put an ls in /temp, well, you're going to run that person's ls if you have the dot at the beginning of your path. So this is where trying to figure out your path stuff actually matters for security purposes on Linux. And so if I just type ls, it's going to pick up the current working directory's ls. And this is something you'll do, I think, in one of your labs is what you'll do. And then I hijacked your ls, and then it does an echo star, and there are now 2 files in that directory, index.html, and then the ls program that you just created. Okay, are there questions about this at all? Okay, I used the star character in that echo star. So what is that? The star character in the shell is a special thing that will match all of the files in the current directory. So you say, this is basically a wildcard. So here's an example. If I touch these 6 files in this directory, I create these 6, and I do an ls of star, it lists all 6 of them, right? So that's what you can do. Within an argument, you have special characters, the square brackets and the curly braces. So these are special argument characters that will expand out your argument into multiple ones based on what you have put into these two. So here's an example of using the square brackets. I say, I want you to ls all the files, which is star, that end with either B or E. That's what the square brackets are. And then this will return AB, and then ABCDE. Okay. The curly braces are similar, but you can actually encode full patterns. So rather than the square brackets are all single characters, but in the curly braces, they could be single characters, or you could actually do a sequence of characters. And it says ls all files that end with C or F. And this will do these two files. I probably should have done like BC or F, just to show you that this doesn't have to be a single character here. Okay, you can use the subsequence notation, which is the dot dot. And so if I do an ls of star and then in curly braces do D dot dot F, this will automatically fill in the E, D, E, and F in order. So this will emit these three files. Ends with a D, ends with an E, ends with an F. So those are those three files. Okay, you can match in the shell a single character. Question, yep.
Does the dot dot, does that specifically do it in alphabetical order? Or
yeah, it assumes alphabetical order, yeah, the dot dot. The question mark will say match exactly one character, but it could be any character. So in this case, if I do an ls of a question mark, there's only one file that has a single character and nothing else, and that's AB. So it matches any file. But if I had AC and I did an ls a question mark, you would have seen AB and AC in this example. The next two are the caret and the bang. So the caret is string substitution on the previous command. So in this case, say I didn't want to do an ls of a question mark. I wanted to do an ls of AB question mark. Well, I can repeat. I could say, you know what? Go to that previous command. Instead of an A, just substitute AB. And then in italics, you'll get this command executing. ls of AB question mark, and then the output will be ABC. These are just shortcuts that you might find come in handy. There are so many of them, but these are things that I've found useful. The other useful one is the bang. The exclamation point, when you use it in the shell, allows you to access the history of your command line. So in this case, if you say bang -7, it says, give me the execution of the command that I executed seven commands ago. So it'll go back in time and it'll go, it'll say you want to do bang -2, you want this command, it'll execute that command. And then bang -7 will go all the way up to here. And then you'll end up executing that command. Yeah.
So if you did like echo bang minus something, it would just show it.
It'll just show you that command, yes. Yep.
So we have a shell where you can't hit the up arrow, you can use that.
Yep. So the question is, yeah, if you can't hit the up arrow, or if you get tired of hitting the up arrow, yeah. And I'll talk about shortcuts for searching your history and for doing all these other things. There's many ways of making your shell navigation more efficient. And I would suggest investing time learning those shortcuts now, because over a career, if you're on Linux as a career, you're going to be saving yourself a lot of time. Yeah.
It'd be cool if they had like a study that showed how many keystrokes you saved.
That would be cool. Yeah. The other one, so I don't have this example. The other one I use a ton is bang $. Bang $is give me the last argument of the previous command. So if I do an ls-l of /temp, and then I say cd bang $, it will cd into /temp. I wish I had put that on there because I use that a lot, the bang $. So that last argument. Maybe I'll do that after, and I'll update the slides with that. Okay, so these are just some shortcuts that you could use, and we're going to talk about a whole bunch of other ones to make your shell navigation really efficient, actually. Okay, the next thing I want to talk about is your history. So that bang accesses your history. The history of your command execution can be accessed using the history command. This is really helpful. So history will list all of the current commands or the recent commands that you've executed. When you exit the shell, that buffer of commands that you've executed on that shell will get written out into a file in your home directory called .bash history. So you can access to all of those things. But it's only on logout that this thing gets updated. So here's an example. History 5 says, give me the last 5 commands I executed, and then dump out that history. So that's what this is showing. And you see that some of these commands, like this history command, doesn't show up in the file, but when I log out, this history command and this cat will get appended to this bash history file. Yep.
Is there a way to erase the history?
There is. History-C clears it. And we'll talk. We'll see that in a second. Oh yeah, there it is. So if you want to wipe out your history, you would remove that file. You would do a history-C to clear it, and then when you run a history, you'll only get the single command. So this is important because one of the things, if you're an adversary and you're on a machine and you want to keep good operational security, you'll want to clear your history. And so this is why I bring up Team TNT. I don't want to pick on them, but like Team TNT, well, one of the things the adversary, so this is a good thing for Team TNT. They're like, you know what? I want to mine the history just in case the user's history will reveal credentials, right? So this is what they did. They basically did a curl and they posted the file, the root's history file, onto this PHP script. It was like, I want to see all the commands that root has executed on this machine. Question? You can do ranges, not regular expressions. You can do some ranges. I'll talk about regular expressions hopefully after the break, but yeah, yep. So here's an example where they're like, okay, I want the root history file. First thing I do is post the history file onto this script, and then I'm going to clear it, clear the history. And I want to make sure that nobody has seen that I've uploaded this history, right? So all of that stuff gets cleared out. And that's basically good operational security. And that's operational security done right. Here is operational security not done right, because if you compromise my machine, I've got all sorts of stuff you can find. Like here, I did this to myself, and I'm like, and then I winced because I have like 10,000 or 15,000 commands in my history, but I don't have important stuff, so that's I don't have valuable stuff on my Linux machine, so that's a good thing. But yeah, if you compromised my machine and you went through my history, you see this command. I ran a Docker container, and I ran this container with an API token. So this is my API token for WordPress scan, and it's right there in my history. So if I had a pro account on WordPress scan, which I don't, you could just wipe out all my resources on WordPress scan and like do a whole bunch of scanning of WordPress if you wanted to. Here's another one. If I have a WordPress if I have a WordPress instance and I have configured it from the command line with environment variables that have the default database username and password in it, and then someone sees this, well, then they're like, well, all I have to do is find where this WordPress site is available, and I can actually connect into that database. So that's another one that you might see. Here's a really bad one. And this is like, if you take the cloud class, this is how we tell you to send your AWS credentials into the container you're running. We're like, yeah, send it in as environment variables. We don't want to see your credentials in the container itself in the file system. So yeah, you would do in the environment variables, like we don't want your credentials inside of the application itself. Like if you put your credentials in the Python code and you commit it, and you push it into your Git repo, you're done. So we're like, okay, put it in your environment variables. And then when you run your application, write your application to pull those environment variables out of the environment and then use them. But of course, if someone has hijacked my machine, they'll see that I set these environment variables so conveniently. And now they've got my AWS credentials. And you do too, except I think I may have twiddled some of these hopefully I twiddled some of these characters so that doesn't wipe me out. Here's another one. You do a Docker build of your container, and then you pass in those environment variables inside container variables. So again, this is in my shell history. And then this is what you would mine if you were to get on my machine. That's what you would use to pivot onto something else. Do you get bonus points for taking out my AWS? So you get $200 worth of. I don't think my credit card backs it. You get you get 200. You can run a crypto miner and get $200 worth of CPU out of it. Yeah. Prepaid. That's true. Yeah. If you want to save yourself. Yeah, I actually ran 2 years ago. I had a project that got compromised in the web and cloud security class. It cost me $3,000, but AWS eventually rolled it back. So like, yeah, $3,000 on your credit card doesn't sound very good. It doesn't. So yeah.
Yeah, just about the command that says, so you history-c, and then it looks like it's like.
The output goes into, so this is in one line. It wipes out that file and it clears the in-memory thing. So when you do a history-c, it clears out the shell's history, and then the output is nothing. So it basically nulls out the bash history file. So that wipes out both at the same time.
Wouldn't then the person know though that it got modified or tampered with, then if it got cleared?
Yes.
Like, why would they want to do that as opposed to just clearing their own?
So so that's great adversarial thinking. Why not just delete the curl? That is totally the better option. And this is the option that I'm going to have you do, maybe in the 5th or 6th week. You're just going to delete the one entry, not the whole thing, right? This is how, but even deleting that one entry, this is how Kevin Mitnick got caught. So Susomu actually was sending these logs off machine. And as soon as you see the log file shrink, then something has happened. And you're even if you shrink this history by one command, like you could detect it if this is being streamed off of the machine. But doing that is much sneakier than wiping out the thing. Like zeroing out everything, that is a red flag that something has happened. And so a little bit sneakier is to just wipe out the one entry, but then there are other ways. Okay. So the next one, that you can use that history, the adversary can use that history to upload credentials. But the other thing that can happen is if the adversary isn't smart enough to hide their tracks, the incident responders can use it to figure out, well, what did the adversary do on my infrastructure? And so here's an example where there was this sophisticated malware. And so the way malware works right now is like these super sophisticated software developers will create the malware, and then they'll sell it to a whole bunch of affiliates, maybe some teenagers looking to make a buck. And the affiliates often don't have good operational security. They'll leverage all this software, but when they are running the software, they don't hide their tracks. And this is where recently, some of these malware authors, they're trying to vet the capabilities of the affiliates, because as soon as an affiliate exposes the malware, like the whole thing gets taken down, right? And so this is just an interesting ecosystem that's out there. So here's an example. There's this Kinsing malware, sophisticated malware authors, unsophisticated OPSEC by the affiliate. And so what happens is they basically were able to go and mine the command history of the affiliate. And then they basically produce this graphic. This is all of the stuff that the affiliate was doing inside of this container that downloaded the malware. And so this is a reconstruction of the operation that the affiliate used. So then they can see the impact, like what other machines are affected and what do I have to do to remediate it? And this is typical for what an incident responder will do. They'll be, when you do a forensic investigation on something or an incident response, you'd be mining this kind of stuff to figure out what might the adversary have done. Okay, so that's an interesting bit.
So this is just like the commands on their own machine because the adversary gains access to it?
Yeah.
Okay.
So the adversary gained access to the machine, and then actually within a container that was running on the machine, did a whole bunch of this stuff, but then the container is still there on that system. And then if you get into the container, you can see that within the container, they didn't clear out the things that they did. And then that's where this mapping, if you can see it, they go into this container and then they do all that history navigation to find out everything that happened on that container, and it didn't get wiped out. Yeah.
Is a container like just a VM?
Similar to, yeah, you can think of it as a virtual operating system running on your real operating system is what a container you can think about. Okay. Some more stuff about command completion and command history. One of the things with command history is that it uses the Emacs bindings by default. Emacs is another editor you could learn. So there's Vim, there's Emacs, or there's VS Code now. And so in the shell, most shells will use the Emacs key bindings to navigate. Now, you could also use the arrow keys, as was mentioned earlier, but Control R is probably the most useful thing to do. You do Control R and then you type a command, and it'll give you the last command that started with the characters that you typed. So if I do a Control R git, it'll give me the last git command that I ran. If I type Control R again on that, it'll scroll through all of the git commands that I've executed in the past. That's probably the best shortcut I can offer you on this slide. After you get the command that you want, then you can use Emacs bindings to edit the command. So maybe you don't want to execute that command exactly the way you had it before. You can use Control E and Control A to get to the end of the line or the beginning of the line. You can use Control F and Control B to go forward and backward on the line, one character at a time. And then edit that command line in place before you execute. Now, there is the equivalent in the arrow keys for doing this stuff as well, but I just wanted to show you that. Control P and Control N to go to the previous and the next command, or if you like up and down. Most people like up and down, but not me, because I don't like up and down. I have to like take my hand off of home in order to do that. Control P and N, like if you're on QWERTY, I don't like doing that. So I do Control P and Control N. Whoops, sorry. And then Control D to exit the shell, or you can type exit if you like old school. Okay, I'm gonna talk briefly about shell scripting before I take a break. It's been a lot. It's often the case that you'll wanna run sets of shell commands programmatically. Now, if you're doing a whole bunch of processing, if you're doing a job that requires a whole bunch of processing, you would typically do that in a programming language proper, like a Python or whatever. But if you have some simple things that you want to do within the shell, then scripting is one of the ways to do it. Within a script, it has conditionals. So in Bash, there's an if-then statement. So there's an if, then, and then fi is basically end if. And that's what they do. They reverse the if to end the if. So here's an example. I set a shell variable to good, and then I can test. And now this square bracket, this is different than the other square brackets I showed you earlier. This is a square bracket by itself rather than part of an argument. And so what the shell does is that this is being evaluated as a conditional. That's what the square brackets in this context is doing. And it says, I don't think these quotes are necessary, but it says if the environment variable or the shell variable true is good, then echo it's true, and then end if, and then you'll get that it's true. There is also an else in the shell that you can do, like if it's true, go here, otherwise echo false. So again, the same statement, and then you echo false instead. Oh, this is if true is equal to no good, and of course it's not, and then you echo false in this case. There are some common flags in shell scripts that you'll come across. The first flag is to check for the existence of a file. So if you want to run something, but you're running something assuming that a file exists, you want to check for that first. And so in this case, I check to see if this file exists in a particular user's home directory. If it does, then I can do something like source the file, right? And then I know it's not going to generate an error because the file exists. So that's one of the things that you would do in the command line, in the shell script itself. I can also check for the existence and the file type. So if I want to check to see if a directory exists so I can cd into it, then I would do a -d on it. So if my shell script assumes that that directory needs to exist, then I'll do a -d. So in this case, hey, you know, if this directory exists, the SSH directory in the user's home directory, then maybe I can access the keys that are in there, or the known hosts, or the authorized keys, whatever I want to do as part of my shell script. The other thing that you'll come across is iteration using loops. So the for, do, and done is the typical loop that you would run. So the for loop, you can do this way. So for a particular variable in this sequence, do the expression of $i. So this variable takes on each one of these variables, or each one of these values. And then you'll run this command for each one of these. So this will print out expr says evaluate this as an expression. And this does simple math. So this is 11, 12, and 13. There are many ways to do a loop and use different arguments for this loop. You can use this loop using shell sequences. So in this case, if I touch these 8 files, so A1 through A4, B1 through B4, I can do something that looks like this. For I in A1 to 3, do an ls of $i. And what this will do is this will list A1, A2, and A3. Okay. I can also use a subshell output. So if I say execute this command and use the output of this command and sequence over the output of this command, I can do something that looks like this. Give me a subshell that executes this sequence command. Seek 1, 2, 1, and 3 will just print out 1, 2, and 3. And I'm just showing you this just to have another way of getting the loop variables. And so this is for I in 1, 2, and 3. Do an ls of $i, and this will print out B1, B2, and B3. The last thing I want to show you is using file system wildcards. And this is a different way of getting the iterator. So I could say for I in A star, and what A star will do is it'll go into the file system and do a file system expansion. And then in this case, I'll maybe move the file $i into $i.txt. And then I'll see that those A1 through A4 got moved from that into A1.txt all the way to A4.txt. Okay, so with that, that was a whole heck of a lot of talking. We're going to talk a little bit more about advanced file and file system navigation. We talked last class about how every file in the file system labels with the type. And you can get that type doing an ls-l. See, oh, that's a directory, that's a link, that's a block device, that's a character device. There is a command called file that does a little bit more. It supports file system types just like you had with ls. So for example, you say file/temp, and it says it's a directory. And not only is it a directory, it's a sticky directory. And we'll talk about what sticky means next class, hopefully, or in 2 classes. You could do a file of dev SDA, and this is a disk, and the disk likes to be accessed in blocks, large chunks of data at a time. So it tells you this is a block device, okay? You could do a file on proc self, and this is a symbolic link that points to the current PID. So you see, oh, this particular command has a PID of 24687. So when I do a file on that, it's a symbolic link to this process. File also supports application level types. And this is implemented as a heuristic. Some heuristic has been written to identify documents and files by a particular type. Okay, one of the things with the file command is that it always assumes a file is only one type. It's not like a non-binary classification like it should be. So you are exactly one thing, is what the file likes to label you as one thing, put you in a box and define you. And so file bin ls is like, oh, well, this is a binary. It's an executable ELF binary, x86 64. Okay, and it tells you, oh, it's dynamically linked. So this is all stuff from like CS201, dynamically linked binary, and it tells you exactly what it is. You could say, well, here's a PDF file. Is it a PDF file? Well, when I type file on it, file thinks it is. And it's not only is it a PDF document, it gives you the version number. You give it an SVG and you say, is this, what kind of file is this? It says it's a scalable vector graphics image. Now it's important to note that file doesn't necessarily just go by the extension, because people lie all the time. You could name a file with any kind of extension, and like, you don't want file to just believe the extension, right? Like, file is actually doing some content analysis, as it turns out. And this is important, especially for the web security class. Like, content types matching and determining content types really matters when it comes to people uploading stuff onto you and you figuring out that data type. So you should never just go by the file extension in and of itself. And so here's an example where there's a JPEG file. I want to figure out what the type is, and it knows JPEG, it parses JPEG, it can figure out the resolution of the JPEG, and so on. So this is a useful first step. This is just a heuristic that we're talking about. The reason why I want to say that this is just a first step, because malicious files seek to get classified as innocuous ones. And files, as it turns out, can be polyglots. They can be two things at the same time. So as an administrator, you're typing file on that PDF file, and you're like, it's a PDF file, it's innocuous. But then the PDF file acts as an executable, and that's not innocuous, even though file told you that, okay? So this is a nice range of subproblems in malware, where you can get a file to look like two different things at the same time. And then the idea is that hopefully the filter identifies it as innocuous, but then the user executes it, and then it's not innocuous. Okay, so probably my favorite talk, one of my favorite talk titles of all time, is this talk from, oh wow, it's like 10 years ago. OMG, WTF PDF, because PDF has got some problems, and it still has some problems. It's like, it's basically allowing you to create a single file that is a zip file, an executable binary, and a PDF that can execute JavaScript all at the same time. So when you type file on a PDF file and it says it's a PDF file, you're like, that's dangerous. That's just not a document. That could be anything. And so there is a database of polyglots that you can find here, and you can bet your adversary is going through these databases and trying to drop files on there that kind of look innocuous, but then actually aren't. So I'm not going to cover this too much though, but here's an example. Here is a JPEG that you can render as a JPEG. And sorry for the resolution here. You know it's a JPEG because JPEGs have in their first 8 bytes this particular pattern and a JFIF. So you're like FFD8, yep, it's got the JFIF, JPEG. And that's what file will do. File will look for those bytes and like, yep, that's a JPEG. But then somewhere in the middle, you can see there's this, I mean, you can't see it, but this is an alert XSS, meaning it's a JavaScript file that can get JavaScript execution. And of course, there's a demo of this. It's got an animated GIF. You load this image up and it's got code execution, JavaScript code execution. Yeah.
So when you do the curl command in Linux, does that identify it by extension or by type?
Oh, so the question is, does curl identify it by the file contents or by the extension. And that, I believe, curl is paying attention to what the server says the type of that file is.
Well, it's true because it'll give like two, like it'll give like if it's a PDF, it'll say like application/PDF. So it kind of looks like it's almost trying to do it with both, or I guess.
Yeah, so that content type header in HTTP. So when you do a curl, and this definitely in the web and cloud security class, when you do a curl, it's going to say, here's what the payload type is. And the browser is just going to assume that that's the server is going to not lie. And so if it says application PDF, it will try and save that as a PDF file locally. If it says application JPEG or image/JPEG, it will try and render it as a JPEG. But then this could still happen because it's still a JPEG. So say I've implanted this JPEG onto the web server, and the web server's like, yeah, well, this is a JPEG for sure. You could download this JPEG from this file and then still get cross-site scripting. So yeah, this is something where polyglot files, this is how you would slide something in and get some execution. Yeah.
So in a nutshell, don't use files if you're trying to audit your system.
Then in a nutshell, don't use file. So they're changing file also. Like, so I assume file is being maintained, but I don't know. Don't trust a single source is what I would say. If you have a suspicious file, don't just use file, upload that sucker to VirusTotal. Like, so I think that's also in the malware class. If you upload the file into VirusTotal and someone has done an analysis that they want to share out, this is what the US government does. They find these things and then they dox them. They expose malware in the content by just uploading it into VirusTotal, and then you get a file. In fact, if I had the actual file content itself, I could upload that into VirusTotal, and it could say, well, these are the things that people have found out about that file, and hopefully it will say polyglot, code execution, and image at the same time. Yep. Yeah, so the comment is this has been around for a long time. That's correct. This has been around for a long time. And so these kind of confusion attacks are very common, where you think it's one thing and it's another. That's a pattern you see everywhere in security, for sure. It's just one of. Okay, so I'm gonna go through some commands that are really useful for you to know when you're navigating things in the shell. The first thing I want to talk about is head, which is just to view the beginning of a file. So here I have a file. It's got 1, 2, 3, 4, 5, and 6, along with the names 1, 2, 3, 4, 5, and 6. And I want to take the first 2 lines out of that file and return it. So that just takes the 2 lines. And then the other part of it is tail. I want to view the end of it. So if I do a tail-2, you get the last 2 lines of that file, as you would expect. The other useful thing is a word count. If I want to figure out the number of characters, the number of lines, the number of words in a particular file, I can use WC. So if I do WC without any flags, then it will give me 3 integers. The first integer is the number of lines in that file, which is 6. The next integer is the number of words in that file. So words are space separated. So, there's 2 words per line. So there's 12. And then the last one is the number of characters. So there are 40 characters here. So that's a useful thing. Yep.
Yeah, I had a question on this typing. So as an adversary, can I forcefully change the type?
As an adversary, can I forcefully change the file type? You mean change the contents of the file to be something else?
So I want to say I'm doing some kind of malicious work and I want that file type to be the particular type. So
Yeah, so that's that polyglot thing. So if I'm an adversary and I want to hide my rootkit as a JPEG, then maybe I could do that in a polyglot. And then when somebody is doing a heuristic scan that's not a deep one, then they'll say image, not a rootkit, no execution, code execution, but then yeah. So you could see this, like if you have, so the ELF binary, you can embed other things in it and try and trick that ELF binary into appearing as something else. It would be one of the things that you would look for as a polyglot. I don't know if you can hijack the ELF binary like that, but that would be the idea. To make that ELF binary look like, I don't know, an HTML file. Okay, the next useful command is the cut command, which will extract fields from the text input. So with this, I'm going to show you the format of Etsy password. So this has got user information in it, and Etsy password has a format where it's colon separated fields. And so if you want to parse this and pull out particular parts of this file of the fields, then you would use cut. And so cut says, using the delimiter of colon, I want you to get field number 1 and field number 3 of Etsy password. And then Etsy password is pretty large. I only want the first field of that. So head -1, and then this will get you this, right? Field number 1 is root, field number 3 is the 0, and then I just take the very first entry, even though Etsy password might be like hundreds of lines long, I take the first line, okay? A more programmatically rich way of doing the same thing is with awk. So awk allows manipulation of the text as you're processing it. Again, it's a line-by-line processor, but you can do more stuff with awk. And I'm not gonna go through a whole bunch of awk, but just know that if you need more, you would do awk. And so this is an equivalent pattern with awk. So awk with a field separator of space. So I'm gonna process file.txt. I'm gonna say, parse this line, each line, and then assume that the fields are separated with a space character. And then I want you to print the second argument in every line. And then this is what you'll get. You'll get the second argument in each one of these lines. Yep.
So for awk, is there a way to remember, like, so the way that I think about bits, I try to think about like what they mean. So does awk stand for something? Is there like a mnemonic for it?
Is there a mnemonic for awk? Not that I remember. Yeah.
Used it when doing stuff with Arch and managing specific.
So I think this is Alfred Aho. I mentioned.
Based off their last names.
Yeah. Okay. Yeah. So the A in awk is Aho. The W is. Do you have it? Okay. There you go. Kernighan. So C. Yep. All right. Cool. Wow. I learn something every day. Okay. Okay. The other really useful command is sort, and it performs a sort on text using a particular field in the line, right? It's doing a line sort, but like in Etsy password, like there are different fields in that line, and you want to sort on a particular field, and that's what the -K flag is for sort. So again, I have that same file. I say sort -K on the second field. And by default, sort is assuming space delimited arguments in your line. So it says, okay, the second key field, and I want you to sort the file alphabetically, as it turns out, unless you give it a numerical flag. Sort this alphabetically, and you'll get this, right? Because this is sorting of this file, and of course, 5, 4, 1, 6, 3, 2, that's alphabetical sorting on the second field. Okay, 2 other useful flags are, I want a numeric sort, not an alphabetical one, and I want to reverse the order on the sort. So in this case, if I say sort -rnk1 of file.txt, it's going to say, take the first field. I want you to reverse sort numerically that file, and then you get that, the thing in reverse. Okay. So to show you how useful sorting is, we're gonna go through this example. Nmap is a tool for scanning networks that you'll use later on in this course. And one of the things that Nmap has is this file called Nmap services, which is kept up to date with the most common ports that people leave open. You're like, you know what? I don't want to scan all 60,000 plus ports. Just scan the top 50, right? And they'll give you the top 50, but it's in this file, and the file is sorted numerically by port number, right? But there's another field in this file based on occurrence. How often is this thing open when I do a scan? So that's the other one. And so I want to figure out, well, give me the top ones. Which are the ones that are open most often? So I'll do something like this. I'll do a sort dash RNK. It needs to be a reverse numeric sort because I want the highest one first, right? And then field number, well, it's field number 3 that is the open frequency that I'm looking for. So it's a service name, port protocol, open frequency. So I want to sort on this one. And then that's the file name. And then I want to get the top 5 in this case. And then it gets you this. HTTP, the Internet Printing Protocol, Simple Network Management Protocol. This is the Samba port for Windows sharing, file sharing, and then the network time port. So then you're like, okay, well, I'll just attack those 5. Well, I'll scan for those 5, and those will be the most prevalent. So that's a useful thing. And I think I might have you do this as part of your lab, just to show you how this works. Another thing that's useful for sort is to sort and then eliminate duplicates to get a unique set of keys off of your sort. So here's just a toy example. Here's a file, ABCAC. I say sort the file and then give me unique lines. And so this will just give me A, B, and C because A and C show up twice. Okay. You could also do the unique function using a separate command, using the unique command itself. And this will remove identical adjacent lines. So if your file is unsorted, then you're going to get duplicates still. But if you sort it first and then you do the unique is only looking for adjacent duplicates. Then you'll get all the duplicates out. So here's an example. I cat file 2.txt, and it's got multiple duplicates. So 3 is there 3 times, 2 is there twice, 1 is there once. If I sort the file alphabetically and then I do a unique, then I'll get 1, 3, and 2. Okay, because that's the alphabetical order. -C is really useful because it can generate counts of identical lines. And this has been useful for me if I want to do a histogram, right? Like if I'm trying to do a histogram, like one of the things I used to do for attendance, I had you fill out a Google form voting for your favorite programming language or favorite piece of malware. And then I was like, I got these votes, but then I needed to do a histogram for who won and what was the distribution. You just do it with this, right? And get all the votes and then do a sort and then a unique and then do a -C. And so if I do sort file 2.txt and I want to generate a unique a histogram with unique keys, I'll just pipe it into that. And then you can see 1 occurs 1 time, 3 occurs 3 times, 2 occurs 2 times. Okay. So putting this all together with pipes and commands and awk and all this other stuff, I want to write a single command, one line command that outputs the number of unique users that are currently logged in. And so this is what I'm doing pictorially here. And so if you type who by itself, so you SSH, in fact, this is what I did over the weekend. I SSH into Linux, I say, who's on here? And of course, there's some instructors on here. So I deleted every student out of here. Jonica's on here. He's the head of CAT. I'm on there. Kevin McGrath, who teaches some of the other security courses here. And then Andrew Tomac is here. And then Root. Root is logged in. And then Root is logged in from Nightshade. So now you can see the number of people that are logged in. You know what the result should return. This should return 5, right? That's what you're looking for. So the first thing you're going to do is I'm going to cut the first field out, right? And I get that. And then what I'm going to do is I'm going to sort the thing. So I'll pipe the output to sort, and then I'll get that. And then what I'm going to do is I'm going to pipe that into unique, and that's what I get. And then I'm going to pipe all of that into word count. And then that returns me 5. So you can see this is the functional composition of utilities on the Unix command line that they're talking about. And you can see, you can run the same thing as a Google Cloud data flow pipeline. This is the kind of stuff they're doing for backend web analytics, right? This is what Snowflake is doing, all this data processing in the cloud, doing this kind of stuff with the amount of analytic data that they're pulling in. So these are operations that you'll find. This is like what data science is about, right? Okay.